Good day, mates. This is your teacher here. We're in Chapter 7, Lesson 2. This one is called Solving Equations Using Addition or Subtraction. So we are on page 302 in our green math books, and we'll start with our learning target. Today it's going to say, I can use inverse operations to find solutions to an equation. I can use inverse operations. I'm actually going to add a couple of words here after that. Inverse operations like addition and subtraction to solve equations. So in our last video, we talked about what an equation is. We know that an equation has to have an equal sign. So in this lesson, we're actually solving some equations. We're trying to try and figure out what some of the variables represent. So at the top of 302, we've got a little bold word there, and it's called solution. Equations may be true for some values and false for others. A solution of an equation is a value that makes the equation true. So we're going to write down what that solution means. So a solution is a value that makes the equation true. So if I give you an equation and I ask you if something is a solution, you should be able to figure out if it is or is not. And not every number is a solution to every equation. And here are some examples. So let's get to a different color here. So in example 1, we're checking solutions. So it says, tell whether the given value is a solution of the equation. So in our work here, we're going to say, is it a solution? Question mark. So that's what we're doing for example 1. So for letter A, it says P plus 10 equals 38. So we have an unknown value plus 10, and it's going to equal 38. And then they tell us over here that P is going to equal 18. And we want to know, is this a solution to this equation? So if P equals 18, what we can do is replace this P with the 18. So we can take the P out of here and instead put an 18 in its position. So 18 plus 10 equals 38 is what we have now. So now we would have to do this addition and figure out, does it in fact equal 38? And 18 plus 10, if we added those together, actually equals 28. So does 28 actually equal 38? It does not. So I'm going to put a slash mark through that equal sign, and my final answer is going to be no. 18 is not a solution to this equation. For item B, the equation they give us is 4y equals 56. And I'm going to remind you that when you have a number and a letter, it means multiplication. So I'm going to put a little time symbol there to remind us. Then over here it tells us, oops, it's not a P this time, it's a Y. They tell us that Y in this case is going to equal 14. So what we have here is 4 times y equals 56. And they want to know if y was 14, if that's a solution. So I'm going to take the y out of the equation and rewrite this with a 14 in its spot instead. So I have 4 times 14 equals 56. So now we have to do this math work, 4 times 14, and see if it does equal 56. And 4 times 14 does, in fact, equal 56. So instead of putting a slash bar through the equal sign, I'm going to keep it just a regular equal sign, and then I'm going to say yes. This is a solution to this equation. If you want to pause the video and try a few more on your own, you can do that now. They're at the bottom of page 302. Okay, so if you tried those, number 1 is no, number 2 is no, number 3 is yes, and number 4 is no. So at the top of page 303, we have another vocabulary word to talk about. It says inverse operations. You can use inverse operations to solve equations. Inverse operations undo each other. Addition and subtraction are inverse operations. So inverse is the same as basically saying opposites. So let's go ahead and write down that word. And we can say undo each other. And what we do with inverse operations is we use these when you're finding solutions to an equation. So use these when finding solutions to equations. So if I have addition, the inverse operation to addition would be subtraction. And vice versa. If I started with subtraction, the inverse operation would be addition. So these undo each other. If we added 4 and then we subtracted 4, that undoes that adding 4. So we're going to use that vocabulary word and that idea when we're looking at our next set of examples. So switching colors here, we'll get back to our examples. Example 2 is solving equations using addition. So they just want us to solve. So I'm going to put the word solve. And item A says x minus 2 equals 6. So some mystery number, take away 2 equals 6. So the way we use inverse operations is we think of what we see, which is subtraction, and what would undo subtraction. Well, if we took away 2, if we wanted to undo taking away 2, we would add 2. So what I like to do is draw a line down our equal bar because our equal sign is kind of like a balance. Whatever's on the left is balanced with what is on the right. So whatever we do to the left side of the equation, we have to also do to the right side. So if I want to undo this subtraction of 2, I'm going to add 2. And since I added 2 to the left, I have to also add 2 to the right of my equation. So if I have a minus 2 and then I have a plus 2, these two things would actually cancel each other out. So I can cross those out because they're inverse operations. Then over here, I have 6 plus 2, and that would equal 8. So my equal sign stays on my line that I drew. The right-hand side of our equation has an 8. And since I've gotten rid of this minus 2 and plus 2, the only thing I have left over there is an x. So this tells me that my mystery letter x is going to equal 8. And I am finished with my equation. So I solved x minus 2 equals 6 by using the inverse operation, and x is going to have to equal 8. The next equation they give us is 18 equals x minus 7. So again, I'm going to start by drawing my line on my equal sign because this is our balance. Whatever we do to the left, we have to do to the right. I see a minus 7 this time. So the inverse of a minus 7 would be to add 7. Since I did that to the right, I have to do it to the left. And a minus 7 plus 7 would cancel each other out because they're inverse operations using the same number. I have an x that's not crossed out over here, so I'm going to bring that down. My equal sign stays on my line, and now I have to add 18 and 7 to get an answer on the left. And 18 plus 7 would give me 25. So the answer to my equation is x equals 25. Go ahead and pause the video and try the 3 on your own at the bottom of 303. All right, number 5 should be k equals 4. Number 6 is n equals 14. And number 7 is r equals 21. So moving on to our next set of examples, we are still talking about inverse operations for these ones, but we're going to be looking at a different operation. So in the last couple equations, we were looking at subtraction, and we had to add to solve. We are now going to be adding, and we'll subtract to solve. So these are going to be example 3 questions. And again, they're asking us to solve. So equation A that they give us is x plus 2 equals 9. We will again start out by drawing our line down the center, be keeping our balance, the right and the left side balance. I see addition this time. So when I see plus 2, the inverse, or to undo that, is going to be to subtract 2. Since I'm subtracting 2 on the left, I also have to subtract 2 on the right. So adding 2 and subtracting 2 would cancel each other out, since those are inverse operations with the same number. And an x is what I'm going to be left with over here. My equal sign stays on my balance bar. And now over here, I have 9 take away 2. 9 take away 2 would give us 7. So my answer to this equation would be x equals 7. And for item B, the equation they give us is 26 equals 11 plus x. So we're going to draw our line down our equal sign. Now this time, if you notice, the x actually comes second. We're still adding 11 with the x though, so we're going to do the same process to get this solved. We're adding an 11, so the inverse of adding an 11 would be to subtract 11. So since I'm subtracting 11 from the right, I have to subtract 11 from the left as well. Adding 11 and subtracting 11 are inverse operations with the same number, so those cancel each other out. And I have an x left over here. I bring down my equal sign on my balance bar, and now I have to subtract 26, take away 11. When I do that, I end up with 15. So the solution to my equation is x equals 15. We have one more example, and this one brings it more into a real life scenario. So let me switch colors here. So this would be example 4. In the middle of page 304 is where I'm reading. Your parents give you $20 to help buy the new pair of shoes shown. So pausing there and looking at the new pair of shoes on the left, there's a little tag on them that says $59.95. So that, I'm sure, will be helpful in our solution. After you buy the shoes, you have $5.50 left. Write and solve an equation to find how much money you had before your parents gave you the $20. So what we're thinking here is we have a certain amount of money that we don't know, and we have to add to that the amount that our parents gave us. But then we had to buy some shoes, so we're going to have to take that away, and we're going to end up with what's left over. So we're going to make a little equation, and then we're going to solve it. So the first thing they give us is that our parents give $20 to buy a pair of shoes that are $59.95. So I'm going to put to buy $59.95 pair of shoes. That's information that they give us in the question. And after we buy them, we have $5.50 left. So we're going to say after ... we have $5.50 left after all of this. And what they want us to do, write and solve an equation for how much money you started with. For how much money we start with. So we are trying to figure out how much money we start with. So that is what's going to be our mystery variable. So if we want to come up with something to represent the money we start with, how about we use an S for the starting amount? So down here, let's define our variable. In our equation, S is going to stand for the starting amount of money. That's what we are trying to solve for. So if we have this starting amount of money, we can put an S down. We have the starting amount. And then our parents also give us $20 on top of that. So we can add to that $20 because they give us $20. Then it says we do buy a pair of shoes. So instead of adding the pair of shoes, we have to take away a certain amount for the shoes. The shoes cost us $59.95. And after we had this money, we got 20 bucks from our parents. We spent money on the shoes. We're going to use an equal sign next because we ended up with $5.50 left over. So this is our little equation based upon what the story is telling us. So we've done the first part. We wrote the equation. Now we need to solve it. So what we can do here is I see a little operation in here that we can actually do to decrease what we've got going on inside of our equation. So if we draw our little line down the equal sign, just like we did up top, and we actually solve the same way, I see subtraction here of $59.95. So what we can do here is do the inverse, which would be to add $59.95. And if we do that to the left of our equation, we have to do that to the right. So I'm going to add $59.95 to the right side of our equation. A minus and a plus of the same number are inverse with the same answer, so we're going to cross those out, and those cancel. Then if we add this side of our equation together, we have 0 plus 5, which would give us 5. 9 plus 5, 14, so let's carry the 1 and write the 4. Our decimal comes in next. 9 plus 5 plus 1 would give us 15, so let's carry the 1. And 5 plus 1 would be 6. So we have 65.45 or $65.45 now on this side. And what we have left over here that's not crossed out is S plus 20. So let's write that down here. So we aren't completely done yet. I don't just have an S on one side. What I do see here, though, is a plus 20. We can go ahead and continue solving this by doing the inverse of plus 20. A plus 20, we're going to undo that by subtracting 20. If we do it on the left, we have to do it on the right. And a plus 20 and minus 20 are inverse operations with the same number, so we cross those out. We keep our S on this side, that's all that's left on here, and then we have to subtract 20 from 65.45. So if we take 20 away, we have $45.45. So our final answer is that we start with $45.45 plus the $20 our parents gave us, subtract the $59.95 for our shoes, and we ended with $5.50. If you'd like to pause and try the last set of on your owns, they're at the bottom of page 304. Okay, so number 8, if you solved, S would equal 9. For number 9, Y equals 3. For number 10, M equals 7. For number 11, the equation would be X minus 8 minus 11 equals 23. And then solving that, you would get X equals 42 blueberries. And that's the end of lesson 2 from chapter 7.